Good morning, participant and course coordinator, sir. Welcome to STC project from HRDC, Ranchi University, Ranchi. I am Anita Sagar, Patliputra University, Patna from Bihar. Today we are going to discuss about the module reviewing of PN junction and overview of BJT from the paper electronic. So participant, let us see what we are going to learn in this module. First, we will discuss about intrinsic and extrinsic semiconductor. Second, we will discuss about Fermi level in semiconductor. Thirdly, we will discuss about how to the PN junction fabrication with the derivation of with the depletion region using depletion approximation. Lastly, the description of current flow at junction. Next, we will discuss about the bipolar junction transistor along with the working of NPN and PNP transistor. We will also discuss about transistor as an amplifier with their input and output characteristic. So participant, let us start basic introductions about the module. A device that locks the current in one direction by the letting current in another direction is called as the diode. Diode can use in a number of ways. For example, a device that uses a batteries often contain diode that project the device. If you insert the batteries backward so the diode simply block any content from leaving the batteries, it is a reverse. This protects the sensitive electronic in the device. Next one is the transistor, which is created by using three layers rather than the two layers used from the diode. Now we create NPN, PNP sandwich. A transmitter can act as switch or an amplifier. A transistor look like two diodes back to back. So you imagine that no current flow through a transistor because back to back diode would block the current in the both ways, and yes, this is true. However, when we apply a small current to the send in circuit, so we are discussion about here only BJT. What is a BJT? A bipolar transistor is a three-terminal device which consists of two p-n junctions formed by sandwiching either p-type or n-type semiconductor material between a pair of opposite type semiconductor. The primary functions of BJT is to increase the strength of a weak signal. It acts as an amplifier. A BJT can also be used as solid state switch in electronic circuit. Working principle of BJT. The emitter-based junctions of BJT is forward biased, whereas the collector-based junction is a reverse bias. The forward bias of the emitter-based junction causes the emitter current to flow, and this emitter current entirely flow in the collector circuits. Therefore, the collector current depends upon the emitter current and nearly equal to the emitter current. Types of BJT. There are two types of BJT, NPN transistor and PNP transistor. In this article, we will discuss in details the working principle of both these types of BJT. NPN transistor. An NPN transistor is composed of two N-type semiconductor material which are separated by a thin layer of P-type semiconductor. The two terminal emitter and collector are taken out from the two N-type semiconductor and the base terminal is from the P-type semiconductor. In BJT symbol, the arrow on the emitter terminal indicates the direction of conventional current in the emitter with forward bias. For non-transistor, the conventional current flows out of the emitter as indicated by the outing arrow. Now here you can see here working of NPN transistor. With the forward bias emitter base junction and reverse bias collector base junction, it can be seen that the forward bias causes the flow of electron from the N-type emitter into the P-type base. This constitutes the emitter current as these electrons flow through the P-type base, they tends to combine with the holes. Since base is lightly topped and very thin, hence only a small number electrons, less than 5%, combine with the holes to remaining more than 95% electrons cross over the base region and reach to the collector region to constitute the collector current. In this manner, the entire emitter current flow in the collector circuits. The emitter current in the sum of base and collector current. Now, second one is PNP transistor. A PNP transistor is composed of two P-type semiconductor which are separated by a thin layer of N-type material. The two terminal emitter and collector are taken out from the two P-type semiconductor layer and the base terminal is from the N-type semiconductor for the PNP transistor. The conventional current flow into the emitter as indicated by the inward arrow. So, working of PNP transistor. For the PNP transistor, the forward bias of emitter bias junction causes the flow of holes in the P-type emitter region forward the N-type base and constitute the emitter current. As these holes cross into the N-type base region, they tends to combine with the electrons. Since the base is lightly topped and very thin, hence only a small number of holes, less than 5%, combine with the electrons. The remaining more than 95% cross the base and reach into the collector region to constitute the collector current. In this manner, the entire emitter current flow into the collector circuit. It may be noted that the current conduction inside the PNP transistor is due to the movement of holes. However, in the external connecting wires, the current is still due to the flow of electrons. Again, the emitter current is the sum of collector current and base current. So, some here important facts about BJT. There are two PN junction, hence a transistor may be regarded as a combination of two back-to-back connection diode. The collector region is wider than both emitter and base. The base is much thinner than both emitter and collector. During the transistor operation, a lots of heat is generated at the collector, hence the collector is made larger to dissipate the heat. A transistor has three sections of doped semiconductor. The one section is called the emitter, the other is called the collector. and the middle section is called the base and the forms two p-n junction between emitter and collector. In general, the emitter base junction of the BJT is made forward biased, whereas the collector base junction is reverse biased. The resistance of forward bias junction is very small as compared to that of the reverse bias junction. The emitter is heavily topped so that it can supply a greater number of charge carriers to the base. The base is lightly topped and very thin, hence it passes most of the charge carriers injected by the emitter to the collector. The doping concentration of the collector region is moderate. BJT biasing. A BJT has two PN junction, emitter base junction and collector base junction. Application of proper DC voltage at the two junction of the BJT is known as BJT or transistor biasing. When a transistor used as an amplifier, the emitter base junction is a forward bias and collector base junction is a reverse biased. If the transistor is operated under the bias condition, then it is said to be operating in the active region. When both the junctions are forward biased, then the transistor is said to be operating in the saturation region. The transistor operated in saturation region act like a closed switch and the collector current become maximum. When both the junctions are reverse biased, the transistor is said to be operating in the cutoff region. The BJT operated in cutoff region act as an open switch and a very small collector current flow from emitter to collector. This current is called reverse leakage current and is due to minority charge carrier electron in p region and holes in a n region. Thank you.